A stretch of pavement in southern China gets hot enough to peel the sole clean off a shoe. Stand on it barefoot for even a handful of seconds, and you'd walk away with a burn, not a suntan. Yet just a few blocks over, in that exact same city, an entire commercial district, dozens of towers, shopping centers, and hotels, stays comfortably cool without a single rooftop AC unit anywhere in sight. The trick is buried underground, hidden somewhere nobody would ever think to look. Nearby, pedestrians stroll straight through a dense white cloud that looks identical to fog, except nobody ever ends up damp. No umbrellas popping open, no soaked shirts, just noticeable relief that seems to arrive from nowhere at all. And here's the strangest twist of all. None of this involves the kind of air conditioning you're currently picturing in your head. This is genuinely happening right now, in 2026. By the time this video wraps up, you'll understand exactly how a can of paint, a buried pipe, and even a small gadget worn around someone's neck are quietly solving one of the biggest challenges facing modern cities today. If that sounds far-fetched, trust me, it only gets stranger from here. Before we continue, if you enjoy videos that introduce you to things you've genuinely never encountered before, tap that like button. It costs you nothing, but it means everything for a channel like this one. And subscribe now, because the final entry on this list might turn out to be the most consequential of them all, so you won't want to miss it. Let's dive in. Heat itself isn't a new phenomenon. Humanity has endured scorching summers for thousands of years already. But something shifted recently, and it shifted fast. Cities began registering temperatures hotter than anything ever recorded in their history. Not marginally hotter, dangerously hotter. Roads that once merely felt warm underfoot now reach temperatures capable of injuring exposed skin instantly. Nighttime hours that used to offer a break from the heat now stay just as brutal as daytime. This isn't purely a weather phenomenon either. It's fundamentally about how modern cities get constructed. Concrete, asphalt, and glass soak up thermal energy all day long like a giant sponge. Then, once night falls, they gradually release that stored heat back into the surrounding air. Researchers refer to this as the urban heat island effect. Essentially, a city transforming itself into its own oven, one that stays warm long after sunset has passed. The obvious solution typically is simply switching on an air conditioner, but air conditioners carry an inherent limitation. They only cool whatever room you happen to be standing inside at that moment. They accomplish nothing whatsoever for the street just outside your window, the open-air market you're walking through, or the bus stop where you're waiting under direct sunlight. Worse still, air conditioners consume massive quantities of electricity, placing enormous strain on power grids at precisely the moment temperatures peak. This creates a peculiar feedback loop. The hotter conditions get outdoors, the harder air conditioners run indoors, which draws even more power from an already strained grid, which occasionally triggers outages during the exact moments people need cooling most desperately. It's a cycle that just keeps reinforcing itself endlessly. So rather than engineering an even more powerful version of the identical machine, several Chinese cities chose to reconsider the entire strategy from scratch. Instead of cooling a single room at a time, what if you could cool an entire street, an entire building, an entire district all at once? That exact question leads directly into our next chapter, because the answer begins with something you've probably already stumbled across online without realizing what it actually was. You may have seen footage resembling this before. A crowded street somewhere in China, pedestrians walking, shopping, eating, and drifting above all of it. A thin white cloud resembling fog that somehow never seems to dissipate. People walk straight through it without hesitation. Nobody bothers opening an umbrella. Nobody complains about dampness, and yet everyone standing beneath that cloud looks noticeably more at ease. That cloud isn't actually fog. It's a cooling mechanism. And the underlying trick turns out to be remarkably straightforward once explained properly. The system forces water through nozzles engineered so precisely fine that what emerges isn't really droplets of water anymore. It's a mist composed of particles so microscopic they never survive the fall to ground level. They vanish into the surrounding air before ever touching a single person below. Here's the crucial part. Converting liquid water into vapor requires energy, and that energy has to originate from somewhere. So it pulls it directly out of the surrounding atmosphere. Every microscopic droplet that evaporates carries away a tiny fraction of ambient heat along with it. One droplet alone barely registers, but multiply that effect across millions of droplets spread throughout a busy street, and the cumulative impact becomes genuinely significant. Within just a few minutes, a system configured like this can drop the ambient temperature in that zone by 5 to 8 degrees Celsius. Not inside some sealed, climate-controlled room, but outdoors, in open air, precisely where controlling heat has traditionally seemed impossible. This approach also turns out to be remarkably inexpensive compared with conventional cooling methods. A standard air conditioner requires a compressor, refrigerant chemicals, and substantial electricity to actively fight against ambient heat. A misting system, by contrast, needs only a pump and a water supply. That's genuinely the entire mechanism. Cities can cool an open-air market, a transit stop, or a busy public square for a fraction of the typical cost, accomplishing something traditional air conditioning could never realistically attempt: cooling wide-open outdoor space. What makes this concept even more valuable is precisely where it gets deployed. Transit stations, outdoor food markets, and popular tourist destinations. All locations where large crowds gather and simply cannot duck into an air-conditioned room whenever they please. A single misting installation can serve hundreds of people simultaneously throughout an entire day, making the effective cost per person remarkably small, compared to equipping every individual with their own personal cooling device. This is merely the opening pattern you'll notice repeating throughout this entire video. Rather than asking how to manufacture cold air, engineers across China began asking how to prevent heat from accumulating in the first place. That shift in thinking eventually led to something considerably more ambitious than mist alone. It led toward altering the weather itself, summoning rainfall essentially on command. Back in 2022, China endured one of the most severe heat waves ever officially recorded. It stretched beyond 60 days and shattered records that had stood since national weather monitoring began all the way back in 1961. Rivers ran dry across entire regions. Riverbeds cracked open under relentless sun exposure. Power stations dependent on flowing water saw output plummet to a fraction of normal capacity, forcing certain factories into temporary shutdowns. Confronted with a crisis of that magnitude, engineers turned toward something that sounds almost too strange to believe. They deliberately attempted to trigger rainfall. This technique is known as cloud seeding, and China currently operates the largest program of its kind found anywhere on the planet. Here's the underlying mechanism. There exists a compound called silver iodide, structured almost identically to natural ice crystals. When introduced into a cloud already carrying moisture, water vapor begins clinging to it and freezing solid. Those forming ice crystals steadily grow heavier and larger until they eventually descend as rainfall. A cloud that might have simply drifted past without releasing anything gets nudged into surrendering the moisture it was quietly holding on to. To deliver silver iodide up into cloud formations, teams rely on rockets, specialized guns firing small rods skyward, aircraft flying directly through cloud layers, and increasingly, large drones. During that 2022 heat wave, one drone remained airborne for several consecutive hours over a severely affected province, dispersing seeding compounds across thousands of square kilometers. Following the operation, temperatures in several areas noticeably dropped, and regions previously desperate for water suddenly had genuine rainfall to work with. What makes this even more striking is the sheer coordination it demands. Weather stations continuously track cloud movement patterns, ground crews prepare equipment on standby, and pilots chart flight paths designed to intersect clouds, carrying sufficient moisture to actually work with. It resembles less a simple switch being flipped and more a meticulously timed operation, requiring everything to align perfectly to produce genuine results. To be entirely fair here, this isn't some kind of magic trick. Cloud seeding functions only when clouds already contain existing moisture. It cannot conjure rainfall from a completely clear, empty sky, and it certainly cannot single-handedly resolve a drought. What it accomplishes is giving a stubborn sky the modest nudge it occasionally needs. And that modest nudge cools ambient air while simultaneously replenishing rivers. But not every solution featured in this story emerges from cutting-edge laboratories or advanced drone engineering. One of the smartest strategies currently deployed across Chinese cities is actually roughly 1,000 years old. Here's something genuinely worth pondering. If people living centuries ago managed to keep their homes cool through brutal summers with zero electricity whatsoever, why did most of the modern world simply forget how they accomplished it? Throughout parts of southern and eastern China, traditional homes were historically constructed around a feature called a sky well. It resembles a narrow, open courtyard positioned directly at the center of the house, rising upward and opening straight to the sky above. At first glance, it appears purely decorative, just a small gap allowing sunlight and rainfall to enter. In reality, though, it functions as a genuine cooling system operating on nothing but elementary physics. Hot air naturally rises upward. Inside a skywell home, the rooms surrounding that tall central opening remain shaded, because the enclosing walls block direct sunlight from ever reaching ground level. That keeps the air near the bottom cool and comparatively dense. Meanwhile, any warm air accumulating inside the house rises and escapes out through the top of the well, functioning almost like smoke drifting up a chimney flue. As that warm air departs, it draws cooler replacement air in from the lower rooms below. The entire structure gradually ventilates itself with no mechanical equipment and zero electricity involved anywhere in the process. What makes this design genuinely ingenious is that it continues functioning even without any breeze outside whatsoever. It requires no external wind to operate, because the temperature differential between the shaded lower rooms and the sun-warmed air near the well's opening generates its own gentle airflow entirely on its own. In a sense, the building manufactures its own private weather pattern, quietly circulating air from top to bottom continuously throughout the day, without anyone ever touching a switch. Research examining these traditional homes has demonstrated that interior spaces can remain several degrees cooler than the surrounding outdoor air during peak heat. Certain skilled craftsmen throughout China have devoted more than 30 years toward mastering how to restore and recreate these architectural designs, and their expertise is now formally recognized as a significant cultural skill worth actively preserving. Here's where things get considerably more interesting still. Engineers eventually realized you don't actually need a genuine open-air courtyard to harness this underlying principle. You simply need to replicate the airflow pattern itself. In Guangdong province, a 68-story tower was designed incorporating internal air channels, functioning almost identically to a traditional skywell, circulating natural airflow throughout the entire structure. A 1,000-year-old architectural concept scaled up into a modern skyscraper, helping cool floors that would otherwise depend entirely on mechanical equipment. While that particular innovation addresses conditions inside buildings, there's another enormous heat source most people never even consider, and it's sitting directly beneath their feet. Glance downward at any road surface on a scorching afternoon. That dark surface you're standing on is quietly one of the biggest reasons your city feels like a furnace, and almost nobody ever notices it. Conventional black asphalt barely reflects any incoming sunlight whatsoever, bouncing back only around 5 to 10%, which means it absorbs nearly everything else. During a hot afternoon, that surface can climb past 60 degrees Celsius, and in certain locations, considerably higher still, hot enough to genuinely injure exposed skin on contact. The problem doesn't end there either. Roads essentially function like a battery storing heat. They soak it up continuously throughout the day, then gradually release it back into the surrounding air overnight, which stands as one of the biggest reasons cities remain uncomfortably warm long after sunset, even while surrounding rural areas cool down normally. This generates a ripple effect, extending well beyond simple discomfort. Hotter roads produce hotter air immediately above them, meaning anyone walking, cycling, or waiting nearby absorbs additional heat they never consented to in the first place. Multiply that across hundreds of kilometers of roadway throughout a single city, and you begin recognizing how something as mundane as pavement becomes a massive, hidden contributor to extreme urban heat. To combat this, several Chinese cities began resurfacing roads using what's called cool pavement technology. This comes in several distinct varieties. Some rely on reflective coatings that bounce sunlight back toward the sky before it converts into stored thermal energy. Others incorporate specialized materials that slow how quickly heat penetrates into the road's lower layers. And some utilize porous materials retaining small amounts of moisture, allowing the road surface to cool itself through evaporation, essentially the identical principle behind that earlier misting system. Real-world testing on these coatings has demonstrated surface temperatures dropping by roughly 7 to 14 degrees Celsius, compared with standard black asphalt under identical sun exposure. Multiply that reduction across every major roadway throughout a city, and you're not merely cooling a single street, you're lowering the temperature across an entire urban area, particularly overnight, when it matters most for residents trying to sleep comfortably. Cooling the ground beneath us helps tremendously, but the next innovation pushes this concept even further. Cooling entire buildings using nothing more than a coat of paint. This next idea sounds nearly impossible the first time you encounter it. A paint you simply brush onto a rooftop, and the building underneath genuinely becomes cooler as a result. No wiring, no electricity, no mechanical equipment involved anywhere in the process. And it continues functioning even while sitting directly beneath blazing sunlight. So how exactly does a simple coating with zero power source make something colder than its surrounding environment? The answer is that it isn't really battling heat directly at all. It's discarding that heat straight out into space. This technology carries the name passive radiative cooling, and it operates through two distinct stages. First, the paint is formulated to reflect almost all incoming sunlight, meaning very little heat ever gets absorbed by the building initially. That portion makes intuitive sense easily enough. A highly reflective surface naturally stays cooler than a dark one. The second stage is where genuine cleverness enters the picture. Everything holding warmth releases heat as infrared radiation. Your skin does this constantly. Roads do it. Buildings do it too. Normally, that emitted heat simply gets absorbed by nearby surfaces and goes nowhere particularly useful. But there exists a specific narrow band of infrared wavelengths that our atmosphere barely obstructs at all. Heat released precisely within that wavelength range travels straight upward through the sky and escapes directly into space, which sits at an unbelievably cold temperature. This specialized paint is engineered to release its absorbed heat exactly within that narrow band, meaning the building essentially dumps its excess warmth into space continuously, around the clock, without requiring a single watt of electricity anywhere in the process. To visualize just how strange this genuinely is, picture the building maintaining a direct connection to the coldest environment imaginable, and using that connection constantly, every second of every day, to quietly discard heat that nothing else nearby knows how to escape. No fan pushes that heat away artificially. No pump relocates it anywhere. It simply departs entirely on its own, straight upward into the night sky. Because the surface sheds heat faster than sunlight can replenish it, it can genuinely end up cooler than the surrounding ambient air, even sitting in direct, unfiltered sunlight. That singular detail is precisely what makes this technology feel almost unbelievable. A research team based in Hong Kong developed a commercially viable version of this paint, and testing revealed dramatic reductions in rooftop surface temperature alongside indoor temperature decreases averaging around 10 degrees Celsius. That translates directly into energy savings reaching as high as 40%, simply because indoor air conditioning units barely need to operate anymore. This coating has already been deployed across hundreds of separate projects, spanning multiple countries worldwide. Cooling one building at a time is genuinely impressive on its own. But the next solution takes this exact concept and applies it across an entire district simultaneously, using a single concealed system. Picture a bustling commercial district packed with office towers, shopping centers, hotels, and residential buildings. The conventional method for cooling all of that would demand thousands of individual air conditioning units, each running its own separate compressor, drawing its own electricity, and functioning entirely independently from every neighboring unit around it. Engineers throughout China examined that arrangement and posed a straightforward question: why cool an entire district using thousands of small, disconnected machines when you could instead cool the whole area using a single, remarkably efficient system? That concept is called district cooling, and within a section of Shenzhen, it currently operates at genuinely massive scale. Several floors beneath street level sits a facility packed with pipes, pumps, and industrial chillers, large enough to resemble a small manufacturing plant. This single facility produces chilled water at industrial volume, then pumps it through insulated piping running beneath city streets, delivering it building after building throughout the entire district. Each individual building simply connects into this shared network, similar to how homes connect into a standard municipal water supply. Chilled water flows inward, absorbs heat from within the building, then flows back to the central plant to be rechilled and recirculated once more. Every building receives its necessary cooling without operating any individual chiller of its own. What makes this system genuinely remarkable is just how invisible the entire operation remains. Walk through that particular business district, and you'd never guess that every surrounding building connects to one enormous machine concealed several floors below ground. There are no noisy units cluttering rooftops, no scattered piping running along exterior walls, none of the usual telltale signs that active cooling is even taking place. It simply functions quietly, entirely out of sight. The efficiency gains achieved here are genuinely substantial. A single system configured like this can cool nearly 3 square kilometers of public buildings collectively. By consolidating everything into one optimized central plant instead of thousands of scattered individual machines, this style of system can conserve well over 100 million kilowatt-hours of electricity annually, while simultaneously avoiding an enormous volume of carbon emissions. Fewer individual machines operating also means substantially less refrigerant circulating overall, which genuinely matters since many refrigerant chemicals prove extremely damaging toward the environment. That represents the city-scale solution. But two of the most fascinating ideas featured in this video have nothing whatsoever to do with cooling buildings or entire districts. They concern the individual person simply standing outdoors amid the heat. Everything covered thus far cools a defined space: a road, a building, a district, even a cloud. But what about someone merely standing outside, waiting for a bus with nowhere available to escape the heat? To address this, cities began installing standalone outdoor cooling units throughout public areas like bus stops, train stations, and busy plazas. These machines simply generate a continuous stream of cool air directed into open public spaces. Rather than needing to duck indoors for relief, that relief arrives directly to you while you're still waiting outside. Many of these units operate entirely on solar power, and the underlying logic here is genuinely brilliant. The most punishing moments of any given day are precisely when these cooling units become most necessary, and those exact moments happen to be when solar panels generate maximum electricity output. The very heat causing discomfort simultaneously functions as the power source resolving it. This self-sufficient design solves a problem that would otherwise severely limit how many units a city could realistically deploy. If each unit required direct wiring into the main electrical grid, expanding coverage across an entire city would prove slow and enormously expensive. But because they run purely on sunlight, cities can position them almost anywhere imaginable, even in locations far removed from existing power infrastructure. letting sunlight handle everything else. Yet the single most widespread solution of all isn't some machine positioned on a street corner. It's something people simply carry along with them everywhere they go. Walk down any Chinese street during peak summer months, and you'll start noticing small devices wrapped around people's necks, quietly blowing cool air directly across their skin. Some models incorporate a tiny built-in water mist for supplementary cooling. Others arrive as lightweight jackets featuring small battery-powered fans stitched directly into the fabric itself. The most advanced neck-worn coolers utilize a compact solid-state cooling chip pressed gently against the back of the neck, a location where blood vessels sit unusually close to the skin's surface. Cooling blood precisely at that spot helps cool the entire body considerably more efficiently overall. These devices have grown from a niche novelty gadget into an everyday essential item relied upon by millions of people. This genuinely matters far more than it might initially appear. Heat-related illness represents a serious medical hazard, particularly for individuals who work or travel outdoors across extended hours. An inexpensive portable cooling device that anyone can carry along and activate the instant conditions start feeling dangerous functions as a genuine safety tool, reaching people in ways no underground plant or reflective roadway ever realistically could. And that concept captures the essential theme running throughout everything you've just learned. Cooling delivered from above using drones, cooling the ground itself using smarter, engineered roadways, cooling rooftops using paint that interacts directly with outer space, cooling entire districts using one concealed underground system, and cooling individual people using something as small and simple as a device worn around the neck. Most places worldwide still treat heat purely as a personal, individual problem, something addressed room by room, person by person. China, meanwhile, has increasingly treated it as public infrastructure, something engineered directly into the fabric of the city itself, the same fundamental way roads and water systems get built and maintained. So here's a genuine question worth considering. Out of everything covered throughout this video, which solution would you personally want to see implemented in your own city? The mist that cools an entire street without leaving anyone damp, the paint that cools a building essentially for free, or perhaps that tiny cooling device fitting neatly around your neck? Let me know down in the comments, because I genuinely read through every single one. If this video shifted how you think about the road beneath your feet or the paint coating some distant rooftop, do one simple thing that helps this channel more than anything else possibly could. Hit like, subscribe, and turn on notifications so the next video reaches you the moment it drops.